based on the conversion of the carbon skeleton of the amino acids. The amino acids are grouped into three classes: glucogenic, ketogenic, both glucogenic and ketogenic. This table is showing us which amino acids are glucogenic, which one are ketogenic, and which one are both glucogenic and ketogenic. Okay, the ketogenic one are leucine, lysine. Glucogenic: alanine, asparagine, cysteine, glutamate, histidine, proline, threonine, arginine, aspartate, glutamate, glycine, methionine, serine, and valine. While isoleucine, phenylalanine, tryptophan, and tyrosine are both glucogenic and ketogenic. The glucogenic amino acids are degraded to pyruvate or to precursors of the tricarboxylic acid cycles, okay, and then can enter gluconeogenesis. Major carbon source for gluconeogenesis are the glucogenic amino acids, okay, are oxidized for energy or stored as glycogen or fats. The ketogenic amino acids are degraded to acetyl-CoA or acetoacetates and cannot be converted to glucose. The ketogenic amino acids are oxidized and used for energy as an energy source in tricarboxylic acid cycle, or can be converted to ketone bodies or even fatty acids. What are the metabolic fate of amino acids? The amino acids may be grouped on the specific keto acid products of their deamination into 3-carbon keto acid, pyruvate, 4-carbon tricarboxylic acid cycle intermediates, which are oxaloacetate, succinyl-CoA, and fumarate. As you know, these biomolecules are 4-carbon atoms molecules. Okay, the 5-carbon atom molecule is alpha-ketoglutarate, which is also tricarboxylic acid cycle intermediates. The amino acids are degraded into pyruvate, of course. They are alanine, glycine, serine, cysteine, and threonine. Okay, so the alanine will be transaminated to yield pyruvate. Okay, we can see this in the diagram. Also, serine can form pyruvate by using the enzyme, or by which enzyme serine dehydratase. Glycine is the product of threonine catabolism and is converted to serine by a reaction which involving tetrahydrofolate. Amino acids that are degraded to pyruvate are asparagine, which is hydrolyzed by asparaginase, yielding aspartate, and aspartate transaminase, which yield oxaloacetate. So, aspartate, as you know, is converted to fumarate in the urea cycle, as we mentioned in the urea cycle lecture. The amino acids that degraded into 4-carbon tricarboxylic acid cycle intermediates, succinyl-CoA, are isoleucine, valine, and methionine. Okay, while propionyl-CoA is an intermediate of this pathway, also is the product of beta oxidation of the odd number, okay, focus, odd number of carbon of fatty acids. The aromatic amino acids, phenylalanine and tyrosine, are catabolized to fumarate and acetoacetate. Methionine is also converted to S-adenosyl methionine, which is abbreviated as SAM. One of the most important reactions is the conversion of SAM S-adenosyl methionine to S-adenosyl homocysteine that can give us homocysteine, which is catabolized to cysteine and to succinyl-CoA. Which amino acids are degraded to 5-carbon atom tricarboxylic acid cycle intermediate alpha ketoglutarate are arginine, glutamate, glutamine, histidine, and proline. The glutamate will deaminated to yield the alpha ketoglutarate. Alpha ketoglutarate is produced from glutamine and glutamate, both of them. Okay? One of the most important reaction or cycle is the glucose-alanine cycle. Okay? In the glucose-alanine cycle, the glucose can enter the muscle directly, and the glucose can form pyruvate, and then the pyruvate can form alanine. Alanine can go direct to the blood, and the alanine can be engulfed by the liver and also will be converted to pyruvate, and the pyruvate can form glucose, and the glucose can then go to the blood and again can enter the muscle.